Okay, welcome back. This is the third video for chapter 2. We're talking about descriptive statistics. And this video, we're going to do all these slides here. So tabular and graphical displays, we've looked at different tables and we've looked at different graphical displays, bar charts, histograms, stem and leaf, and then also we looked at dot plots. Summarizing, but now we're going to look at summarizing data for two variables using tables and two variables using graphical displays. Because everything we've looked at so far has been one variable. It's been like, how many days does an audit take? Or, which soda did somebody choose? And so now we're going to look at two variables. And so thus far, we focused on methods that are used to summarize data for one variable. Often the decision maker is interested in tabular or graphical methods that will help illustrate the relationship between two variables. And one of the ways we could display the relationship between two variables is like a cross-tabulation. And so cross-tabulation, here's an example. We have cross information. So quality rating of a restaurant and then the price of the meal. And some people, 42 people said it was good, 34 people said it was very good, and 2 people said it was excellent. Or there's 2 restaurants that rank excellent. There's 34 that rank very good, and there's 42 that rank good in the $10 to $19 range. And then in the $40 to $49 range, there's 22 excellent restaurants, there's 6 very good restaurants, and there's 0 good restaurants, right? So the higher the meal price, the higher the quality of the restaurant is what this shows. And so cross-tabulation is a tabular is another word for table. It's a tabular summary of data. My hand smells like gas a little bit for some reason. I'm not sure why, like gas you'd put in your car. Cross-tabulation is a tabular summary of data for two variables. Cross-tabulation can be used when one variable is categorical and the other is quantitative, or when both variables are categorical, qualitative, or when both variables are quantitative. So you could do a cross-tabulation with any type of data, the same or different. The left and top margin labels define the classes of the two variables. So here is this class. This is qualitative, categorical, good, very good, excellent. And this is quantitative. What was the price of the meal, right? And if you fell into these ranges, then you fell into these classes. So that's an example. You can pause the video and look at it. And then here is interpretation of that. So you could pause the video and you could read this. And then here is percentages, right? So row and column percentages. So 50%, 47.6, and 2.4 of the restaurants that were good fell into these classes for prices. And then of excellent, right, there was 3% that were in this price range, which were excellent, but 42% were in this price range and were excellent. So that's looking at it that way. And then here we have row percentages, so it shows you how it was calculated. So 42 divided by 84 times 100 is equal to 50%. And that 42 comes from right here. 42 divided by 84 gives you the percentage for that one right there. So the percentage is like, this one item out of divided by the whole, right? What percentage is this one item out of the whole? If I have a pizza with 10 slices and I have 2 of the slices, 2 divided by 10 is 20%. That's how you calculate the percentage. That's what that's showing right there. There's this idea known as Simpson's paradox. We're not really going to spend this is the only amount of time we're going to spend on it, is what I'm going to say about it right here. And Simpson's paradox is the idea that the data alone can convey one thing, and then when you do cross-tabulation, it gives you like the exact opposite meaning. So that's a paradox, and it arises sometimes, and we'll ask ChatGPT, can you please explain Simpson's paradox in statistics and provide me with a simple example to illustrate that. All right, so we'll come back to that in a second. We'll let that generate, and we'll move on to the next one. summarizing data for two variables using graphical displays. So we could do scatter diagrams and trend lines. So that's really useful for exploring the relationship between two variables. So in most cases, graphical display is more useful than table for recognizing patterns and trends. Displaying data in creative ways can lead to powerful insights. So here is like a trend line, scatter diagram with a trend line. And so we scattered the data and we could see the trend is like a positive relationship. So that's one way we could display data, scatter diagram with a trend line. And here we describe a scatter diagram and a trend line a little bit. Scatter diagram is graphical presentation of the relationship between two quantitative variables. One variable is shown on the horizontal axis, the other is on the vertical. The general pattern of the plotted points suggests the overall relationship between the variables. A trend line provides an approximation of the relationship. And so here we have like, restaurant price increases left to right, and we have restaurant quality increases bottom to top. As the price goes up, right, the quality goes up. It's got a positive relationship between price and quality. One of my favorite, examples of this is Gapminder tools. And so Gapminder tools is amazing. And you come in here and you go to Gapminder tools, and then we want to, this is exactly the one we want right here. And so this shows the GDP and life expectancy for each country. So this is the wealth of a country, gross domestic product per capita per individual. And this is the life expectancy. So if you live in that country, how long are you going to live? And this is the data for 2022. The color of the country shows the different regions. Here are the Americas. Here is South America. Here is I guess that's Asia, and this is like Europe and Russia up here. And you could see that down in the Africas, down in Africa, you make less money, right? So the poorest country in the world is down here. It's South Sudan. They make $386 a year. The richest country in the world is like, I don't know, by hair's breadth right here. And I can't even get my mouse over it. What is it? Luxembourg and Ireland. Oh, that's super interesting. They make $114,000 per year per person in Ireland. Luxembourg is $116,000 per person, and Singapore is $108,000 per person. USA is $65,000, $64,700 per person. You can see that down on the bottom axes, the horizontal axes. And in the USA, you live to 78 years. In Japan, right here, you live to 85.2 years. So, it's pretty cool to see how this data, two different variables, and how this, what do they call this, a scatter diagram, how this scatter diagram shows the different countries. And the size of the ball, by the way, is the population of the country. So there's a lot of information on this, this display, which is incredible. And then even more incredible, you could come down here and you could do this scrub head, and you see the years changing, but you also see how the data changed. And so if you move this, you could really see, right, from, the 1900s, early 1900s, life expectancy wasn't that high. America was still the richest country, and you lived to 50.4 years on average, right? But, down here in China, they were poor, and you only lived to 36. But as over the last 100 years, the Industrial Revolution, right? Like things really increase. And right here, you can see the balls all drop. Life expectancy is going down. And that life expectancy dropping is World War II. So you can see this ball here, a lot of people died. And that was Russia, right? Like a lot of people died in Russia in World War II. Which other country had a lot of people died? This one right here, Indonesia. Interesting. A lot of people died in Indonesia in World War II. Here's another big one right here, Germany, right? Obviously, a lot of people died in Germany. Life expectancy really took a big drop for Germany right there, went way down. And America up there, that green ball, life expectancy stayed pretty good during World War II. And then after World War II, post-World War II, the world's really seen a time of prosperity, health, and wealth, right? Life expectancy, health, GDP per capita, wealth. Bit of prosperity, like incredible prosperity that's never been known before. We live longer than we've ever lived, and we have more wealth than we've ever had. And you can see that the trend line here is more vertical, right? So there's more disparity between how long people live. Like right here, trend line is pretty vertical. It's going sort of like that. But today that trend line is more flat, right? So everybody's experiencing better life expectancy. So the worst countries, you're living to 64, 51, and the best countries, you're living to 85. So still some discrepancy there, but it's more flat. Anyhow, I love it. I love that scatter diagram, and that's gapminder.org tools. So here's the information that they gave us about Simpson's paradox. And you could pause the video, you could read through this, and then I'm going to scroll down, and you could pause the video and you could read through that. And it shows aggregated data can sometimes be misleading, and it's crucial to consider the structure and context of the data. That's all you need to know about Simpson's paradox. So here's a positive relationship between data. As X increases, Y increases. Here's a negative relationship. As X increases, Y decreases. So as you smoke more cigarettes, your life expectancy goes down. Right? That's negative relationship, negative correlation. And here's no apparent relationship. All right, next slide is a scatter diagram with some data. So here's the week. Here's the number of commercials that were run for that week, and here are the sales. We would expect a positive relationship between the number of commercials that were run and an increase in sales. The more we advertise, the more we sell. And then here's that scatter diagram, a description of it. So you could pause the video and you could read that. And then we could do a side-by-side chart. And so here's the restaurant data. What price category were you in, and what quality were you? So in the 10 to 19 price category, we have a lot of good restaurants, some very good, few excellent. In the $40 to $49 price range, we have more excellent than and a few very good and no good. And then here were the most excellent restaurants. You can see the dark blue, right? And so that data there is easier to interpret. And you could also do a stacked bar chart. And so in this price range, you can see the percentage that were good, very good, and excellent. This is all out of 100%. You can see that over here on the vertical axes. And at this price range, you can see that the vast majority, $40 to $49, the vast majority are excellent, some are good. So it's a stacked bar chart. You can pause the video and you can read that. Data visualization, best practices in creating effective graphical displays. The goal is to communicate effectively and clearly the key information about the data. Your goal might also be to get a certain outcome and to mislead people about data, which people come up with and do all the time. You want to try to create some sort of a case. And so if you're going to financial investment opportunities with a financial planner, like they will present very specific data to present a certain image. And you got to be super careful and just question all of it and know that this, just because they're presenting data doesn't mean that this is actually reality. It's one picture of reality, and that's a picture they've chosen to show you. So, that's different than the goal is to communicate effectively and clearly reality. It's a slice of reality or a moment in time. Data visualization describes the use of graphical displays to summarize and present information about a data set. Creating effective graphical displays, pause the video, you can read that, and here's what we looked at. So we saw bar charts, pie charts, dot plots, histograms, stem and leaf display. We saw dot plots, that's there. Side-by-side bar chart and then stacked bar chart. And so this was the side-by-side, and then this was the stacked bar chart. So we saw those. And then show relationships. We saw a scatter diagram. We saw a trend line. And so then we finally have data dashboards. This is like a data dashboard. When you're driving and you're looking at the dashboard in your car with speedometer, fuel, temperature, right? Like whatever other stuff they have there. Odometer, speed, that's the speedometer, RPMs, like all of that, fuel efficiency. Like all of that is a dashboard in your car, giving you information about your car. They have data dashboards for cars. That's literally your dashboard when you're driving. Your display, the driver's display in front of the steering wheel. But they also have dashboards for all kinds of things. So here's a dashboard to help run a call center. And it's got information so that the manager can see, how is my call center operating today? and they can look at it and they can make adjustments to try to get the numbers to do what they want them to do. So here's a little explanation of a dashboard. And those dashboards are organized to help businesses achieve certain key performance indicators, right? And to keep their eye on key performance indicators. Number of customers coming into the store, right? Like that's a key performance indicator. The more customers that come in the store, the more we sell. Let's keep track about how many customers are coming into the store every hour. When are they coming in, right? That's a KPI, a key performance indicator we want to track, or whatever it might be. So here's a summary of everything we went through in this chapter, and generally how we use the different stuff that we looked at based upon whether it's qualitative, aka categorical data, or quantitative data, and whether we're displaying it in a table or in some sort of a chart or graph. And you can pause the video and read through this. Hope you enjoyed it. One more video. I'm going to go through the assignments with you. See you in the next video.